Hello everyone, I'm Jake. Let me introduce the Mars Texture Projector, which is one of the tools in the Mars Master Material series of products I created. This tool is mainly intended to be combined with current AI technology because AI can create a series of diverse textures and it is very, very fast. So what we want to do now is to add such a tool to the 3D workflow, which will enable us to quickly generate a variety of textures. Its basic principle is similar to camera-based projection in current mainstream 3D software. You can see that this is in the UE scene. In this scene, we use this tool. Our texture projector has 6 directions: positive X, negative X, positive Y, positive Z, and negative Z. The first step is to obtain the information of our model in UE the scene. The model information mainly includes the following 3 types. The first is the depth map. The second one is the contour map, and finally there is the normal map. In this case, you can see its depth map, line art contour map. There is also this normal map, which contains normal information based on screen space. With these 3 types of maps, we can feed the 2-dimensional basic 3-dimensional information of the model contained in the data to control net. We use common AI tools such as ComfyUI or A1111 to generate the textures we want. This is the basic texture generation process. After we generate the model information for all directions, we generate all the textures. You can see that this is the completion of the second step. Then we can project this set of 6 directional textures back to the existing scene through our texture projector, and the model will have a very beautiful appearance. Now we need to update its depth map. We are currently using the 6-sided version of the tool. First, select the rig in the scene and load it. Then select the model and update its material. You can see that this is a case I completed before, which is a Buddha head from the southern and northern dynasties of China. This is a perfect 6-sided map, and it's seamless. Use Texture Projector to read the textures in 6 directions and automatically project them back into the scene, and you're done. Finally, another tool is involved called Property Baker. We can use it to bake our 6 textures into a complete texture based on UV space. These are 2 baked maps, 2 UV quadrants combined into 1 UDIM map in UE. Next, we will introduce the complete operation process of Texture Projector. Open these 2 plugins before using Texture Projector. The first one is Blueprint Material and Texture Nodes. The other one is Editor Scripting Utilities. The UE version I am using now is 4.25. Texture Projector is compatible with the latest version 5.3. The current scene only has lights and a Buddha head model. Please note that because texture baking is involved, there cannot be any fog-related nodes in the scene. Models can come from a variety of generation methods such as handmade, scanned, or created by AI. But the most important thing is that its UVs need to be unfolded and cannot overlap. So now let's start operating step by step. First, find the Texture Projector widget. There are two versions of Texture Projector. The first version is followed by the one-shot suffix, which specifically refers to the projection of only one camera angle. The version without the one-shot suffix contains 6 cameras, pointing in the 6 directions of positive X, positive Y, positive Z, and negative Z. When to use the single camera version? If the camera movement in the scene is very limited and only part of the observed object is visible and one camera projection suffices, we can just use the one-shot version. Note that the scene can support up to 6 one-shot versions and the projection direction can be adjusted according to actual needs. This is the biggest difference between the two versions. Let me add a little more explanation on the difference between the two versions. Please see the comparison table in the document, such as the difference between rig, the difference in scenes used, the difference between window operations and projection capture. If you are interested, you can take a closer look. Let's try this 6-camera version. Right-click and select Run Editor Utility widget to open it. This is its main interface. First, select our Buddha head model and click Create Projection Rig to create a projection camera group. Texture Projector will create 6 default cameras around the pivot of the object. There are 6 camera previews in the interface. You can click on each preview to select the corresponding camera to control its detailed settings. For example, I can switch the camera's projection type and there are 2 options. The first is orthographic mode and the second is perspective mode. This choice is based on your personal preference. I personally prefer orthogonal mode as the texture will be less deformed due to perspective. When orthographic mode is selected, ortho width can be used to adjust the projection range and can also control the size of the object in the texture. Please note that in perspective mode, it will be adjusted through field of view. I'm making adjustments for each camera. The default projection angle is along the axis direction, which is suitable for models that are also facing the axis direction. Similar to this Buddha head, it can perfectly cover the model surface without any deflection angle. If we do need a declination angle, we can select the root object of the projection rig to rotate. After rotating it, I need to click refresh to update it, get the picture seen by the camera, and fine-tune the projection range. Please note that after the camera is rotated, its Z-axis will tilt instead of facing the positive Z-axis, causing the image to tilt. Click Fix Camera Z to adjust to ensure that the up direction of the model coincides with the up direction of the texture, which is more effective for texture production. Now let me reset the rotation information to 0, fix Camera Z again, and click Refresh to restore it. The camera's offset setting can control the texture offset. Roll angle can rotate the view. Offset X is the depth direction of the camera. Offset Y is the left and right direction of the image. And offset Z is the up and down direction of the image. After adjusting the offset and roll angle of each camera, the camera settings are almost ready. Texture resolution controls the resolution of the captured image. The default 1024 is fine. This menu can switch the display channel, which is now the color channel, and can be switched to the normal channel, but this is based on the world space. We are going to use normal CS, the normal based on camera space, but note that the direction of the ControlNet normal map is opposite to that of UE. Please see the comparison table on the right. Another channel that needs to be used is depth information. The default is automatic recognition, and you can also choose to customize it. The automatic recognition will be estimated based on the model size. If you feel that the effect is not very good, you can choose to customize the numerical adjustment. The last channel that needs to be used is the outline information, which also has corresponding settings, such as outline threshold, line thickness, and contrast. After all the adjustment is completed, we can bake all the images. Of course, you can also choose to export the current image or all images of the current camera. Click Bake All Images, and Texture Projector will store all the images in the content root directory. You can move them to your own directory. Each image will indicate the direction and channel, such as positive X direction, D represents depth, L represents outline, and NC represents camera space normal. The next step is to create the all-important projection material. Because there are 6 viewing angles, it is a 6-layer material. It is recommended to use LM material, which is layered material, or you can also choose MALG, which is material attribute layers. Depending on your operating habits, just click Create. The projection material will also be stored in the content root directory. This material records all the information of each projection camera. After we create the textures in all directions, we will use this material to project the textures back into the UE scene. After obtaining all the two-dimensional 3D information of the model, we will export all the images to our AI production process. Be careful not to select the red images. These are 32-bit depth maps that must be used in the UE environment. These are the images for all 6 directions. Please note that color channel images are also available. We can let ControlNet's pre-processing analyze it and generate the required depth, outline, and normal maps. But now that we have UE, we can use more accurate 3-dimensional data. Okay, let's start creating our texture in ComfyUI. What you see now is my custom workflow. First, enter the positive prompt. In addition to the accurate description of the Buddha's head, there is also the most important lighting prompt. Panoramic lighting is added here. When the texture is drawn, there is a high probability of panoramic lighting and avoiding strong shadows. For negative prompt, shiny and reflection need to be added to reduce highlights, and rim light can also be added to reduce rim light. We use 512 resolution textures. It is recommended to use the DPMPP series for the sampler. More detailed suggestions are provided later. I'll change the project name, by the way. In the ControlNet module, we need 3 control bars: use simple mode, open them all, and use default parameters. Run it once first and enable the corresponding layer of ControlNet. I have copied all the images used to the input directory of ComfyUI in advance. Now let's take the front view as an example and select the depth map, outline map, and normal map of the negative Y angle in sequence. Enable Allura to add a little detail to the texture. Use FreeU to increase the detail of the picture and use Rescale CFG to reduce contrast. Another very important thing is that in order to increase the consistency of the texture, I have enabled the IP adapter. I randomly selected a reference, and in order to weaken the control effect, lower the weight value and also lower the endpoint value. The model uses Dream Shaper and the VAE uses the official default one. The setup is basically complete. More detailed suggestions will be provided later. Enable the basic process for this case. No more complex settings are required. Then after confirming the effect, we turn on high definition upscale and now start running. It can be seen that the tone of the image is greatly affected by the reference image, and the endpoint value of the IP adapter can be reduced to about 0.15. Note that this is not demonstrated in action. Turn the CFG down slightly and run it in batches. Next, I used A1111 to create the textures. I used the same prompts and parameters but changed the model to absolute reality, which is more realistic. ControlNet uses 4 channels: depth, line art, normal, and reference. Enable high resolution fix, scale to 1024 resolution, 20 steps, and set noise to 0.3. The image created with the seed number is shown on the right. I will create the other 5 images next. What you see now are the textures I created and selected using ComfyUI and A1111. The SD15 and SDXL models were also compared. The recommended parameters are displayed in the right window. Generally speaking, if you are using SDXL model, it is recommended to use ComfyUI to create it, which will be better in terms of efficiency and effect. The above 6 were created in A1111 using the official default SDXL model. The results are difficult to control and the creation is slow. After this set of textures was completed, I did not look for more suitable ones. The bottom 6 were created in ComfyUI using an SDXL model and getting great results on the first run for the front angle. Maybe I was lucky, so I used the same seed number for the other shots. Images created with SDXL models are very detailed. Pay attention to this one at the base of the Buddha's head. When I made it, I didn't adjust the prompt word, so a face appeared. If you want to adjust it, change it to bottom of a flat stone. Judging from the final result, this set of textures produced using the SDXL model in ComfyUI has the best effect. If you use the SD15 model, the results created in ComfyUI or A1111 are acceptable. Please pay attention to the set of textures below. Because there are no shiny, reflections and rim light added to the negative prompt, there are obvious highlights and rim lights in the picture. Although the overall light feeling is very beautiful, it is not suitable for use as a texture. In this area, the lighting prompts are compared and other parameters are consistent. This image uses the ambient occlusion and the effect is okay, but the Buddha's face is a bit white. This one uses hemisphere light. To sum up, in the positive prompt, you need to add these light settings to have a greater chance of obtaining uniform lighting. Among them, I personally like panoramic light and soft ambient. In negative prompt, add shiny, reflections, rim light, and even shadows. This has a greater chance of reducing the interference of the corresponding effect, but the shadow removal effect is not obvious. It should also be noted that the CFG value used by the SD15 model is relatively high, such as around 8, while the SDXL model uses around 3. The SD15 model is matched with 3 control net channels, including depth, line art, and normal. But when using the SDXL model, just one depth channel is enough. After some tests, in this case, it was found that the existing line art and normal calculation models suitable for SDXL models are not ideal and may even cause errors and cannot be executed. Next, we go back to UI and project these sets of pictures onto the Buddha head model to see the final effect. First, I made a copy of the Buddha head model. The position of the copied model will be offset and needs to be adjusted to be consistent with the original model. Here I reset the position value to 0. Find the projection material you just created and apply it to the copied Buddha head model. By the way, I've sorted out the directory structure. I need to update the camera information and depth information in the material. Open the texture projector, select rig and load it, select the projected material and update it. Open the projection material. Let's first check the mask of the texture in each direction. Turn off this option, switch from the texture mode to the mask mode, and check the 3 positive directions. This is the positive X direction. The depth shadow mask is enabled by default. The surface of the model seen from the camera is masked, and the mask is 0 where it is not visible from the camera. If the depth shadow mask is turned off, you can see that although the area on the back is blocked by the model itself and cannot be seen in the camera because its normal is facing the camera, the direction mask still works. This will cause the texture to appear in this area as well, which is not what we want to see, so be sure to enable the depth shadow mask. Direction mask is also enabled by default. If you turn it off and only keep the depth shadow mask, you can see that the mask will appear very sharp and messy, which is not conducive to texture blending, so it also needs to be enabled. This smoothness value can control the attenuation in the transition area. The smaller the value, the wider the attenuation range. The larger the value, the smaller the attenuation range. Then look at the positive Y direction. The positive Y direction is the back of the model, and the yellow area is the transition area between the positive X and positive Y directions. The positive Z direction is the bottom of the model. Note that there is a little problem here. There is some masks in the area behind the model's head, but we don't need to use the bottom texture in this area, so I'm going to remove them. Enable the distance mask. The default attenuation distance value is equal to the distance from the camera to the model pivot. I reduced this value appropriately. Reduced to 150, the mask is essentially gone. Let's check the positive Y direction separately. Enable all three positive directions. Next, check the negative directions. In the negative Z direction, we only need the mask for the top of the head, and we need to remove the mask for the face and torso. So a distance mask needs to be added. We retain some masks in the forehead area. In the future, the texture of this part will be covered by the front texture, so there is no problem. The negative directions are also checked and all are enabled. Then switch back to the texture mode. The projected texture is white by default. You can see that the entire surface of the model is covered and the model changes from black to white. Now that the mask has been adjusted, let's load in the textures. Apply the textures to the corresponding location. Okay, let's take a look at the final result. Very nice and requires almost no adjustment. Let's try to improve it a little bit from the layer relationship. First of all, we want the frontal texture, that is, the negative Y direction texture, to be placed at the top when compositing. There are 6 layers from 1 to 6. The higher the layer number, the higher up the layer. The sequence number parameter of the layer corresponds to the texture number, and the number of the negative Y direction texture is 5. So the 6th layer corresponds to the number 5, which is the negative Y direction texture. The texture at the bottom of the model, that is, in the positive Z direction, is placed in layer 1 and the texture number is 3. Then place the top, left, right, and back textures in order. Please note that Texture Projector is camera-based projection after all. Therefore, the texture will not be attached to the model's surface, and moving the model and camera groups simultaneously will not work because the camera's transform data is not updated in real time into the projection material. Even if we convert the projection data into the model's local space coordinate system and let the projection transform follow the model to achieve the attachment effect, the 6-layer projection material, which includes calculations of spatial transformation and mask fusion, is too complex and inefficient. So what I want to do is bake it into one texture. Enable the Projected Materials Bake Properties option and close the Material Editor window. Find the Property Baker widget and run it, choose the model we want to bake, then hit the Select button. Enable the three-dimensional space property option to unwrap UVs. Enable the UV dilation option to weaken texture seams at UV boundaries. Enable Unwrap Preview and the model is unfolded in UV space. You can see that this Buddha head model contains two UV quadrants. The scene did not bake lights, so the base color attribute, which is the original texture, was selected for baking. Regarding the detailed settings of Property Baker, I will arrange a separate video introduction. Select the texture resolution of 2048, click the Bake Texture button, and the result is stored in the Content Root directory. When I opened the texture, I found that the color space displayed was wrong. This is a bug in version 4.25 of UE. Restarting UE will display it correctly, or if I update the texture parameters such as turning off sRGB and enabling it again, the texture color will be displayed correctly. At the same time, the texture is expanded at the UV boundary. You can also use the Texture Sample Dilator widget to enhance the expansion effect. For the texture in the second quadrant of the UV, I just move it one unit in the U direction and bake another one. In order to obtain UDIM maps that can be recognized by UE, we export these two textures to the system directory and change their names. The texture for the first UV quadrant is suffixed with 1001 and the texture for the second UV quadrant is suffixed with 1002. Then import these two textures back into UE so that the UDIM map that merges the two UV quadrants is completed. Create an unlit material and import the texture. Copy a Buddha head model and apply the material instance to it. Next, we replace another set of textures to see the result. Although we have achieved good results, there is still one small problem, which is the background layer. Before baking the texture, we enable the background color and turn it to red so you can see it immediately. When blending masks, there will be some areas that are not filled, causing the background layer to be visible. In this case, especially the negative Z direction texture, we need to improve it further and try turning off the direction mask and distance mask. The problem at the top has been solved, but the shoulder area is not ideal, so enable the distance mask and increase the distance to 250. To improve the shoulder area, you need to color the background layer so that it matches the existing texture. or try enabling background layer texture. The material also provides UV tiling and rotation functions for the texture, but they were not demonstrated in the video. If you want to continue to improve the realism of the material, then I recommend using Materialize to quickly generate the required textures. Texture Projector is also suitable for indoor scenes. Whether using the one-shot version or the 6-camera version, the operation process is the same. But I need to remind you that if you want to bake the map, you need to reorganize the UVs of multiple objects in the scene, consider them as a whole, effectively use the UV space and disperse them in several UV quadrants. Please open the documentation and scene for more details. I have listed the product and document links involved in the video in the description. Thank you all for watching. I hope you like the Mars Master Material Series products.